Hello friends, welcome to my next tutorial on data wrangling tutorial series, the ultimate guide to data wrangling with Python using Rust Polars DataFrame to work with finance and supply chain data analytics. In first few videos, we learned about Polars DataFrame and we created some dummy data for finance and supply chain. We also learned about data types, IO, context, and expression. In today's video, we are going to learn everything about functions, user-defined functions, and Windows functions. I want to call out that you will find link to source code in video description below, and you can reach out to me at GitHub, Twitter, and YouTube. If you haven't already, please consider subscribing to this channel for more videos. As I mentioned earlier, in this notebook, we are going to focus on using Polar expression to work with Polar functions, user-defined functions, and Windows functions. So this is the Jupyter notebook from previous session, and if you recall, we did create a lot of sample data from finance and supply chain data models. So as you can see, Polar provides a large number of built-in functions using Polar expressions. So first we are going to just review a couple of examples, Polar functions which are delivered out of the box. So let's go first run that import Polars SPL. I'm going to create one very simple data frame, and this is the example you will find from the documentation as well. So here pl.dataframe, and I'm going to create first series, say A, and it has three values, say 1, 2, 3, and another column series is 10, 20, 30. So for example, in this case, what if you want to apply some simple expression, say you want to sum it up. So I'm going to use Polar expressions, built-in functions, you can say built-in functions through Polar expression. So pl.call, and let's select the first column, say A, and suppose you want to sum it up, you want to add it up to column B. Simply what you can do, just simple plus sign. So here in this case, as you can see, plus sign is a function you are applying under different Polar columns here. Now similarly, you can you can have more functions, Polar expressions, say dot mean or minimum or maximum, and please go through the signature of those functions if you want to know what this function does. So pl.call on the column A, you calculate the mean, similarly minimum and maximum. Now let me run this data frame and see what it looks like. So as you can see, it simply applies those functions on different columns, columns on the data frame. Now let's go back to the data frame what we created. So if you recall, in previous session, we created a balance sheet data ledger data frame which has like approximately 100,000 rows. So again, just to recap, this particular ledger data frame, it has a ledger type, and from fiscal year to fiscal year, and it has following fields: a ledger, organization, fiscal year, accounting period, which is from January to December, and some random numbers from asset, liability, revenue, and network account. So let's just run this. So this typically represents a typical financial statement, so that you have some data to work with. Now in this example, let's assume that you have been asked to do some algebraic operations. So for example, you already have the four fields there: asset, liability, revenue, and network, and all of a sudden you realize that some of the calculation is not right. So let's assume that network right now is populated with the random number here, as you can see, and instead of using the random number, we want to use some formula. Let's say simple formula is like asset plus revenue minus liability, and when you have these three fields, that's how you calculate network. Network is equals to asset plus revenue minus liability. Now instead of using the random number, so in this case what we are going to do, we want to create a new column which perform this simple algebraic operations. Now there are different ways of doing it. Here I'm showing you first way of doing these things using simple Polar expression as simple Polar functions here. Now there's another scenario. Now assume that you have been asked to generate a unique string which is a cost center. So suppose you have been asked, okay, let's go combine, put these columns in together, say ledger, organization plus physical year, and create a unique column, something like that, some key column, etc. So this is the second scenario we are going to handle. So let's go, take our original data frame what we created, balance sheet, and we are going to call the with columns context because we want to generate extra columns here. Here, simply what I'm going to do, I'm going to take the column, say assets and plus liability, and I'm going to sum those up. Asset plus revenue, and then I'm going to subtract the liability from them, right? And simply I'm just going to alias it with say network underscore C because there is already column say network underscore C. Now second condition, if you have to concatenate that, so ledger plus org plus fiscal year. All right, it's as simple as that. I'm going to convert this to UTF, a UTF string here. So now let's go print it out. So that's how you do simple algebraic operations. Okay, it's very simple. It's just using the Polar inbuilt expressions, and those are going to be very, very fast. All right. So as you can see now, my network calculation is is right. It's not using the random numbers and is based on some algebraic operations. Similarly, as you can see, cost center has been generated and it concatenates those three fields here. Now let's add some more complex to this. Now assume that instead of say there's one field that one field and you want to do some algebraic calculations, you want to do some complex calculations on that particular field. So for example, in liability field, you want to calculate some interest rate. So on liability, suppose you loan some money from somebody else and you are supposed to pay some interest on that liability. So we are going to use this formula, which is a very simple formula, that interest equals to principal amount in the bracket 1 plus rate divided by compound interest to the power n times number of months, number of years. So we are going to use this formula. So in this condition, what if I ask you, you have to apply this formula on each and every row. So in this case, it becomes little bit complex. Now again, there are multiple ways of doing it. I will show you how you can, calculate do some algebraic operation or apply a function on a particular row. So let's take this example here, and to the correct way of doing it, do not just create a function here and throw something out there. The correct way of doing it, please use the Python oops methods here. I will show you how to do that. So first I'm going to create a liability class here. It's a very simple class. So I'm going to import the random number class liability, and inside the class liability I'm going to define an init method. So what it does, and before you define the init method, I want to define all of the values it takes. So to accurately calculate the liability, you must know the principal amount, n is rate of the interest type, compound interest type, rate is the rate of interest, and t is the time. And then you properly initiate that class, so that whenever you create an object of that particular class, all the methods where you create inside that particular class will be applicable to that object. You will see that in a minute what I mean by that. Here simply what I'm doing, when you initiate that class, is accepting those parameters, say principal, p, n, r, and t. All right, now let's go define a particular method, say self loan interest, and what it does, the formula what we have just shown you, I equals to p times 1 plus r divided by n. I'm going to apply that formula. I'm going to just code that formula here, and it's not a complex formula, it's a simple algebraic operation. So 1 plus self divided by rate divided by self dot compound, and to the power self dot compound times self dot time. All right, so now my class is defined. My interface is defined to calculate the liability interest type. Now simply what we need to do, because it's returning a tuple of interest and total, so I'm returning two different values here. All right, so now my class interface is ready. Now all I need to do, I just need to, whenever I'm doing some calculation, I will create an instance of this class, so that all the methods and properties already defined on that class will be available to me. Okay. So let's create a wrapper function, say get interest, and inside that get interest, if I pass, suppose I want to calculate some interest on this particular amount. So what this method does is simply accept one parameter, and here I'm going to define some defaults. Say compound interest type is 1, say rate of interest is 2.875, 60 is the number of the months, and here d equals to, I'm going to create an instance of the liability class what we have defined earlier, d, and I'm going to pass all these values here, and then simply call this method d.get loan interest. So that's the reason I defined that whole liability interface, so that all the methods and properties are available to me. All right, so now my oops interface is complete, and I have a method which I can use inside my polar expression here. Now simply go back to our balance sheet data frame one more time, and here what we want to do here, say out equals to balance sheet dot with columns, and let's select that column, say liability. So pl dot call liability, and on this liability I'm going to, initially it was map and apply, but now I think polar has changed, and there's a new method called map elements. What map elements does, it takes a function and it applies that function on each and every row, one column at a time. Okay, so as you can see, it will take liability for each row on that liability column, and is going to apply that get interest function. So once you see that in action, see, simply it calculates all the interest on the liability. All right, so that's how you apply it. So this is actually, I defined it. So just to recap, I defined a user defined function, and I'm calling that user defined function on this particular polar data frame. So we just learned how to create user-defined functions properly and how to apply those user-defined functions on a polar data frame as an expression. Now, ideally, what I wanted to call out here, please pay attention to that. When you are working with millions and trillions of rows, then it becomes very, very important how you are doing these algebraic operations, because for simple data sets it doesn't matter, but for huge data set you will get in trouble always. So as much as you can, please try to rely on Polar's built-in expression, because when you are using the Polar built-in expression, so simply like what we did, I'm going to duplicate all of the things what we did earlier. Here I'm hard coding this compound rate equals to this, t equals to this, and instead of doing all that thing what we did, creating methods and all that, I could have done that in Polar expression itself. So if it's in simple enough algebraic operations, please try to do that as much as you can inside the Polar expression. And the reason is very, very simple, because here you are still working with the built-in underneath Rust multi-thread framework kind of a system, right? Because Polar is built on Rust, so obviously it's going to be very, very fast. If you use some external Python functions, every time you have to call that function, it might slow you down. So please, it's always very recommended that as much as possible, wherever applicable, please try to use Polar's expression for algebraic calculation, as much as possible. As you can see, simply what I'm doing, whatever the calculation I've done, this is not a very complex calculation. So all I'm doing, pl.cost liability dot map elements, and I'm using that lambda functions here, and I'm just hard coding whatever I did. So looks a little bit complex because it's not in Python OOPS interface, but here simply I'm just doing the same calculation here inside that Polar expression. So you will get the similar results. All right. So I think that's pretty much I wanted to cover from the user-defined functions perspective. Now let's go, work on the Windows function. About Windows functions, what I want to mention here, think about Windows functions are simple Polar expression with superpowers. Because superpowers in the sense, because they allow you to run multiple Polar expressions all together in parallel. Think about for example, you want to do lot of group by or other aggregations on different groups on some certain columns here. So instead of you want to run it on a multiple different column from different perspective. So let's take another example here. Going back to our balance sheet data frame. So here, for example, you want to calculate, you want to do some, so you want to know the mean value on my network by fiscal year and accounting period. Same thing, I want to do some other different operation on revenue column or some other column here. So what you want to do, you can calculate, you can run the parallel expressions on certain columns in parallel. So for example, here I'm just saying, let's take the network, let's calculate the mean of the network, and at the same time do something else on the revenue. So let's take another example here. It will be more clear to you. So going back to this balance sheet. So here you have ledger, organization, fiscal year, asset, liability, and all the four columns here. So as you can see on the network, I'm calculating the mean. And on the revenue, I want to calculate the mean, but I want to do a different group by. So that's what I meant by that you can run different algebraic grouping operations on different columns, but in parallel. So here is another syntax here. So for example, I want to know my, all the mean values or the sum of all the network account values by fiscal year and accounting period. I mean the column 1 and column 2 or column 3. So simply what you can do, you can just actually I would have done like that. But here, instead if you use the syntax say dot over by fiscal year, it applies then Polar expression understands that you are calling out a Windows function here, and you can do that in parallel. So that's the beauty of our Windows function, is that it lets you run those grouping or aggregations on different columns in parallel. So I think that's pretty much it. That's all I wanted to cover from the functions perspective. And in the next section, we are going to work on data transformation. I hope you find this video useful. If you have any questions, please feel free to reach out to me, my GitHub account, or open an issue log on my GitHub, and I'll be happy to help you out. Thank you very much.